Bismillahirrahmanirrahim. This video will be solving question number 9.2 from Mr. Hyatt's book, and this is related to parallel RLC circuit. And there's a request from a student to solve this. Although the question is very simple, but Mr. Hyatt has just assumed many things that a common student probably do not recall. So I'll just try to add to whatever is given in the book to make it slightly simpler, I hope. So I'll follow this sequence of action, and as we go, you will learn what it is. This is the question, and we have to find the capacitor voltage VCT. So this is the capacitor voltage for time t greater than 0. Now, if you recall, I have learned that the first thing we will do is to find the before t0 value of the inductor current and the capacitor voltage. It is called I0 and V0 minus. And in some books, instead of I, it is written IL. And instead of just V, it is written VC. So this is more explicit. This gives a clear picture. So I'll follow this. Now, let's see what is happening. Before t is equal to 0, this circuit is open. It is closing at t is equal to 0. That means we can remove this whole thing. And since it is open for a long time, we'll assume that it is in a steady state condition. And in steady state condition, the inductor behaves like a short circuit and the capacitor behaves like an open circuit. And so we'll deal with this circuit. Now, we are assuming a current direction. We could have assumed it like this as well, but I'm assuming it from counterclockwise because IL current is also in the same direction. One more thing that I have marked the voltage polarity. So wherever the current touches first, so it is touching here first, so this will be positive. I'm talking of this current I, not IR. I touching here first, so it will be positive and this end negative. Similarly, I touching this end first, so it will be positive and negative. So with this circuit now, we can write the KVL equation. You can go from any direction. In this particular case, I'm going counterclockwise. So it will be 200 into this voltage I, 200 ohm into I will be this voltage, then plus 300 into I, plus 300 into I, and plus 150 volt equals 0. And so from here we can calculate I. Remember this I is actually IL0, or we can say I0 minus. Anyway, I from here will be minus 0.3 ampere. And so IL0 is equal to I is equal to also minus 0.3 ampere. What about VC? Now in VC you have to keep in mind that this polarity is already marked in the question, that is positive at the top and negative at the bottom. But because of our current, it is opposite, the positive at the bottom and negative at the top. That means we have to reverse the size, the sign to find VC. So we can write VC0 is minus this voltage drop here, minus this voltage drop, and this is VR200, I'm calling it, and this is actually equal to minus 200 and IL, this is IL0, putting in the value, so it will be 60 volts. So this voltage at 0 minus will be 60 volts. So that is the initial voltage. Now the second part, we will now move to the t greater than 0. And t greater than 0, this is now, the switch is closed, so it's a kind of a short circuit. And now if you note, this voltage is only flowing current through this, no current in this loop. And therefore, we can neglect this part. And so our circuit will be simply as shown here. And this, there is no source other than the voltage charged here already. So that is why this circuit is called source-free RLC circuit. A couple of things. One, if you keep this time diagram in mind, this is 0 point. Just before that is 0 minus, and just after that is 0 plus. So there is a property of inductor and capacitor that the inductor current and the capacitor voltage do not change instantaneously. So whatever is the current here will be same here. Whatever is the capacitor voltage here will be same here. So we can say that IL0 plus is equal to IL0 minus is equal to minus 0.3 ampere. And similarly, voltage VC0 plus is VC0 minus, which we have calculated to be 60 volt. The next thing is the circuit. Keep in mind that we are at immediately after t greater than 0. So if you look at this diagram, immediately after t0, actually this is the transient period that the capacitor is charging. And so in that period, we cannot make the inductor short circuit or the capacitor open circuit. So that is why I have just written it that the circuit is in transient condition. And so both of these items are present. Number 2 is the current has now become IL0 plus, and this voltage has now become VC0 plus because we are after t greater than 0. And now the second step is that we calculate alpha, omega, and S, the roots. Let's first calculate alpha. This is the formula given. And plugging in the value of R and C from here. Remember, the only value of R or C that will apply is for the circuit at t greater than 0. So we are using this value. So 12500 is the alpha. And this is formula for omega, so 100,000. And now to find Vt, we have to go to the conditions. Now these are the 3 conditions. If alpha is greater than omega, then we'll use this equation. If alpha is equal to 0, we'll use the second equation. And if alpha is less than omega naught, it will use the third equation. So these are called the overdamped case, critically damped case, and underdamped case. Now in our case, you can see alpha is greater than omega naught. Alpha is greater than omega naught, therefore it is overdamped case. So we'll use this equation. This is the equation we're going to solve. Now S1 and S2 are not known here. Again, we'll take help of the formula. This is the formula for S1. So just plugging in the value of alpha and omega. And similarly, S2, same formula except for the sign change, positive here and negative here. So we have calculated S1 and S2 and plugging in here, Pt or Vct will be now A1 e raised to the power S1 plus A2 e raised to the power S2t. Okay, so we have found this, and now we need to find alpha A1 and A2 from this relation that we found out. And to find this, we have to also use dV/dt. So we'll see that. First of all, we put t is equal to 0 in this equation. So this term will become 0. So e raised to the power 0 will be 1. That is only A1, it is only A2 and VC0. VC0 we have already calculated. This one is VC0, or you can say VC0 plus. This is 60, and therefore from this equation we get our equation number 2, that A1 plus A2 is equal to 60. But these are two variables, and to find both of them we need another equation. To get the second equation, we have to differentiate equation number 1. We differentiate this, and this is the differential equation. And here also again we'll put t is equal to 0. Putting t is equal to 0, this will be 0. Remember there is a t, we are just not writing it here. This is 0. This one is also 1, and this one will also become 1. So this is the relation. Now we don't know how much is dVc dt. So for this, we'll have to go back to the circuit and try to find this value. Okay? This is our circuit. We need to find this up to this point we are here. So we know one thing, that the current through the capacitor can be written as T dVc dt. So if you apply the KCL equation to find IC, then we can find dVc dt. Let's see, all three currents going out from, let's say this is the node, so going out, going out, going out. So IC 0 plus, IL 0 plus, and IR 0 plus equal to 0. We are interested in IC, so we keep that in the left and they move these two in the right hand side. And this one we can write dVc dt. IL0 is I0 was minus 3 we had found from here, so we'll plug that value in. Now IR0 plus, we have to see from here, IR0 plus is actually this voltage divided by resistance. Now this voltage VC0 we have found out already, so we will use that. That is 60. So VC0 over 200. That means it is minus minus plus 3, and minus this is 60 divided by 200. So this will also be 0.3. So the answer is 0. So C dVc dt is 0. Therefore dVc dt is also 0, because it here will be 0. We will now put in this value in our equation 3. From equation 3, now we can write that 0 is equal to this. Taking common minus sign and the 5000, so it will be A1 plus 4A2, 0. This is our fourth equation. So we have now these two equations, and now we can easily find the value of A1 and A2. Solving these two equations, A1 will be 80 and A2 will be minus 20. Plugging in into the voltage equation that we had got so far. So A1 is 80 and A2 is minus 20. So this is the answer, and this is valid for t greater than 0. I hope you have been able to follow this. Please let me know through your comments. Thank you.